Hello, everybody, and welcome to the first webinar of our series on the FED4SAE success stories. So my name is Alice. I work for Blumorpho as an innovation business developer, and today I will be moderating this webinar on AI computer vision using Intel's Movidius VPU platforms and the success stories from the FED4SAE project. So before we start, I'd like to inform you that this webinar will be recorded and the video uploaded on our YouTube channel. If you'd like to receive the slides, don't hesitate to send us an email and I will send them over to you. You can see the email address now on the screen. Also, there is a question box in the toolbox on the right side of your screen. So please don't hesitate to address your questions throughout the webinar and we will answer them at the very end of this webinar during our Q&A session. On this note, please don't forget to specify the person you're addressing the question to so we can answer them properly. So before we start, we have a question for you in the audience in order to get to know you a bit better. So you should now see the question popping up on your screen. So I'll give you a few seconds to answer the questions. The question is, do you currently have some project under design? Again, I'll leave you a few seconds to answer the question so you can take a bit of time. All right, so I will close this poll in 3, 2, 1. All right, so thank you everybody for your answers. We will now move forward with this webinar. So today this webinar will be the first of a series. The first one will focus on the success stories of FED4SAE project using Intel's Movidius VPU platforms. The next one will take place on the 19th of May, and we will focus on the STM32 microcontroller from ST Microelectronics. And then the last one will happen on the 2nd of June, same time at 10 a.m. And we will focus on Thales and AVL's platforms. So today I am very happy to welcome Finian Rogers with us, who will help me moderate this webinar. Finian, who is the R&D program manager at Intel. So hello, Finian.
Good morning. Hi, Alice. Nice to be here.
We also have with us today Jamal El-Yousefi from Intel, who is C application engineer. Hello, Jamal.
Hello, Ali.
And then for our two success stories of the day, I'm very pleased to welcome firstly Fintan Buckley from the company UBOTICA. Hello, Fintan.
Good morning, Alice. Good morning, everyone.
And Mohamed Al-Haddad from ISSD. Hello, Mohamed.
Hello and good morning.
All right, so thank you everybody for being here today. Before I give the floor to Jamal El-Yousefi, I'd like to give you a few information on the FED4SAE project. So what was the FED4SAE project? It was a consortium of 13 partners in 10 countries. On this project, there was a budget of 7.6 million euros, and out of this, 6.9 million euros came from the European Commission. On this project, we ran 3 open calls to get access to cascade funding. So these 3 open calls took place in November 2017, May 2018, and December 2018. We had 165 registrations, 116 submissions in 26 countries, and 32 projects were selected in 13 countries. 1.8 million euros were given in cascade funding. All right, so thank you everybody for listening. I will now give the floor to Jamal El-Yousefi from Intel, who will tell you a bit more on Intel's AI strategy. So Jamal, the floor is yours.
Okay, thank you, Alice, and good morning, everyone. Okay, I will. So I am Jamal El-Yousefi. I am senior software application engineer at Intel. I am a member of the Intel Computer Vision and Deep Learning team. and I am based in Paris. ISSD is one of the customer and partner I have supported in implementing and optimizing the Intel OpenVINO development kit. So I have to click to get to the next slide. You can hear me?
Yes.
No, yes.
Okay. So to support our customer in developing and deploying their computer vision solution, we start first by understanding their use case, and then we help them to select the right software and hardware. For some use cases, a Movidius VPU may be enough to run the inference at real time. But for other cases, a more powerful accelerator may be required to meet the expected performances. This is exactly what we did with the ISSD. Okay, you can see the slide now. Accelerate your AI journey with Intel. Okay, so in fact there are 4 main steps to implement and deploy your AI solution. The first one is to discover what is possible and how to get started. At Intel, we are used to deliver many workshops to our customer and partner, either on-site or online. The second step is to get your data ready for training. And as you know, labeling the data may be the most time-consuming task. The third step is to train your deep learning model. And the final one is to implement your application and to deploy it. And for the second and third step, you can use some open sources model, or you can use one of the pre-trained model provided for free by Intel. For the data labeling and the model training, this is maybe done many times during your life cycle or application to fine-tune your model. So we'll go. There is some latency, so as you know, in deep learning there are 2 main processes: the training and the inference. For the training is very important because for the success of your project, the accuracy of your model is very important to make the success of your project. And we during this presentation, I will give you a quick overview of the Intel deep learning inference engine called OpenVINO. Sorry, I have some latency. Alice, on which side you are now?
So I can see Intel Computer Vision portfolio. Is it the one you want?
Okay. I had not, because there is some latency in here. Sorry. So this is the Intel Computer Vision portfolio for typical use cases. You can use the TensorFlow a framework to train your model. And then once your model is ready, you can use the Intel distribution of OpenVINO toolkit to make the inference for a specific model using different accelerator. At Intel, we have really different accelerator. We have CPU, Core, or Atom, or Xeon server. We have the GPU, integrated GPU. We have the FPGA, it's the dedicated hardware accelerator, and also the Movidius, the stick. In the next slide, I will give you a quick overview of the Intel distribution of OpenVINO, the one being used by ISSD for their computer vision project.
Do you want to change slides, Shana?
And because there is some delay, and change it.
Okay, now it has changed.
Okay, now it's
see
okay.
it now.
Okay. So this is the what's inside the Intel distribution of OpenVINO toolkit. In fact, there are two main components inside this toolkit: the model optimizer and the inference engine. The model optimizer will help you to convert any framework-based model to what is called intermediate representation format used by OpenVINO. So you have first to convert offline your model to this format, and this format may be 32, FP16, or int8. You have different floating point precision. And then once your format is ready, you can use the OpenVINO engine to run the inference on different accelerator. So you can, for example, prototype your project on your laptop using the CPU as accelerator, and then when everything works fine, you can move to your target accelerator and target platform by changing only one line in your application. This is very important because we have only to change the name of the target device. For example, from CPU to Movidius, from CPU to FPGA, and so on. You have only to change one line, and OpenVINO toolkit will be in charge of loading the right accelerator for you. So we have two interfaces for inference engine. We have one in C++ and one in Python. So you have choice between the two languages. The toolkit also comes with more than 40 pre-trained models for different use cases. You have some models for the object detection, image classification, image segmentation, face recognition, text detection, and so on. We have really many different pre-trained models. We have also different samples for also different use cases. And we have the model downloader to download the Intel pre-trained model from internet, or also to download some open source model like AlexNet, SqueezeNet, Inception V3. So this model optimizer is a Python script that you can help you to download the right version for a specific model. And we have different also tools inside this distribution. The most important for you at the beginning would be the benchmark application. These tools will help you to benchmark any model on different platforms with different accelerator. It's very simple Python application to use, and it can as output you will give you for specific model the FPS, the latency, and other performance numbers. Any questions so far on OpenVINO toolkit?
kind reminder to the audience, you can ask your questions in the question box, in the toolbox in the right side of the screen, but we will address them at the end of the webinar in the Q&A session.
Okay. So this is the workflow of any of OpenVINO application. This is very important to know. So imagine you would like to make object detection for detecting cars. So the first step, you must have your model ready. Once it's ready, you have to run the model optimizer offline to create the IR format. You will have two files, .xml for the topology of your model, and one .bin, which is the weight of your model. Then you can use the OpenCV or Intel Media SDK to decode your video stream. And then you have to pre-process the video stream before inferencing. Sometimes it is required to resize your input frame to the resolution required by the model. In this case, you can use OpenCV. Once your frame is ready for inferencing, you can run the inference. There is only some few function of inference engine to help you to run the inference on a specific accelerator. The most as accelerator, we have CPU, GPU is the Intel integrated GPU, FPGA, VPU for Movidius neural stick, and at the end of the inference, we have to make some post-processing. As example of post-processing is to draw the bounding box around the detected object. As you can see on the right, the red bounding box. And then you can use the Intel Media SDK or OpenCV to encode your output as a video to be streamed or to be stored on your disk. So this is the typical workflow for any OpenVINO based application. So we will skip this one because this is only show how the Intel DL Boost feature can accelerate the performances on the second generation of the Intel Xiant processor. We'll directly move to, this is the hardware we have today for inferencing. We have FPGA, Movidius, many CPU cores, Xiant server, and also we have the integrated graphics card. Now I will, try. This is the Intel Movidius neural stick compute. In fact, Myriad X is a dedicated hardware accelerator for running on device the deep neural network application with ultra low power profile. This is very important for some application that require low power for the application. For example, video surveillance camera. This is maybe very a good choice. Myriad X is the second gen VPU from Intel. It can be found in millions of devices today, such as video surveillance camera, and it can be found in different form factor. We have it as a single VPU USB stick. You can have it in mini PCI card form factor with two up to or three with two or four VPU Movidius, and we have what is called HDDL, which is the high density deep learning board, and we can it can contain up to 8 Myriad X VPU. And this is the one HDDL is the one being used today by ISSD in their ongoing computer vision project. So in fact, in OpenVINO, we have different plugins. We have one plugin for the CPU, one plugin for integrated GPU, one plugin for FPGA, and one plugin for the compute stick. So you have to write only one application, and you have only to change the one line in your application if you want to move from one accelerator to another. So if, for example, you can prototype your application on your laptop, and then run move your application to the FPGA by changing only the target device, and this can save a lot of time for you. I think it's.
Clement, you wish to switch slides?
Yeah, because it takes time waiting for to move. Yeah. Yeah. Okay. This is compare the performance of the current generation and the previous generation. In fact, the Myriad X is the second generation of the Intel compute stick. It's up to time faster than the first generation. This is only the average. Sometimes it's 15 to 20 times faster than the Intel first generation. Yeah, here are some information how you can find more information about OpenVINO, Myriad X, and also please don't hesitate to contact me if you have any question or request regarding OpenVINO. Or I can also, if you are just starting your implemented your use case, you can send me an email. We can set up a conf call to help you in choosing the right software and the right hardware for your application.
Okay, so thank you very much, Jamal, for your presentation. So before I give the floor to Finian, same as last time, he had a question for you. So you should now see popping the question on your screen. So question is, where are you in your AI journey? I will give you a few seconds to answer the question. So in the meantime, as a reminder, please don't hesitate to send your questions in the question box on the right side of the screen. Our keynote speaker will answer them during the Q&A session. All right, I'll give you a few more seconds to answer, and I will close the poll. It's 3, 2, 1. Okay, so thank you very much for your answers. I will now give the floor to Finian Rogers, who will now give you some example on how the VPU platforms have been used successfully in the frame of FED4SAE. Finian, the floor is yours.
Very good. Hey, thanks, Elise, and thanks, Jamal. Okay, so let's see if I can take control of the presentation deck. Great. Okay, yeah, that's all good. Okay, hi, folks. So this is just an overview of the FED4SAE program, just to explain this term of application experiments. What is that term, and what are these? So in the framework, SMEs, you can see the life cycle of the program. So SMEs on the left-hand side had to choose either a vertical platform or a horizontal platform. So vertical platforms from Thales and from AVL, and horizontal platforms from either ST or from Intel. And we offer two different platforms for companies to innovate upon, either the Movidius neural compute stick or the compute card. And if they chose those horizontal platforms, they had to combine it with a advanced technology or test bed from the RTOs. The RTOs are the research and technology organizations spread across Europe. So CEA, Fraunhofer, KTH, and Fortis, to name but a few, offered a range of their advanced technologies in their test beds. And these were then referenced in a proposal, and we provided a template to applicants, and we provided help and coaching. And those then proposals were submitted aligned to those calls, and they were independently evaluated by an external panel. And then that led to the selection and funding of 32 application experiments. And they ran for anywhere, one or two ran for a short 6 months, but majority of them ran for a period of 12 to 18 months. And they're all going on in parallel. A lot of them are still in flight at the moment. And the participants in those application experiments receive about 60K funding, a bit underneath that. They got technical coaching, they got platform support, and they got technical coaching from the RTOs or from the platform providers. And the whole goal of these application experiments, and they are experiments in the nature of the term, they are hopefully successful, but they can fail, and they can be learnings and refinement as the projects proceed. And so the goal is for them to actually come out of the experiment with a prototype that has been validated, ideally in a customer site, and the customer says, yes, this solves my problem, this meets my need. And then Blue Morpho, our colleagues on the line, help with venture capital funding and pitching and investment advice to those SMEs to help them to scale in whatever vertical industry that they're targeting. And so this is the point where Intel now gets really excited to say, okay, wow, you've got a proven solution that's solving a customer's need. How can we help you scale? Because that's what Intel is all about, scaling. Okay. Now I'm going to move to the next slide. Okay, so the next slide shows us, okay, here then is here is the network that is created as a result of all of these engagements. So you can see we have platform providers, advanced technologies and test beds, and we have the SMEs. And you can see then there's a cluster of SMEs and their projects around the STM32 platform, and you'll hear about that in the next webinar. And you'll hear in this one about the neural compute stick and the compute card. And you can see that there's on the bottom side of the slide, I don't know if you can see my mouse pointer, you can see that there's 7 or 8 application experiments in the neural compute stick. Okay. Great, next slide. Okay, and so as a result of this, from Intel's perspective, then we have these application experiments that are, as I said, that are referenced either the compute card or the Myriad in CS. And this slide is again a busy slide, but it gives you the overview and the diversity of application experiments. And it shows how AI is applicable in a range of different industries. So just to quickly summarize, on the left-hand side, we see video upscaling. So a company is looking at taking low-quality, say 720K images and broadcasting them at low resolution and then upscaling at the edge. In the area of hand hygiene, can I track the movement of the hands of doctors and nurses and provide them real-time feedback as to the quality of their hand washing protocol? In the AR/VR space, a company is looking at using EEG interfaces and providing feedback to the user, to the system to provide content-specific training to the user to help them with their learning process. So if I had an issue in learning in a certain area, the system would infer that and would offer me different content or a different learning style. Aerodrums, we're looking at the virtual drumming kit. Number 6 was looking at melanoma detection. So using a hyperspectral camera, you can provide early insights into melanoma at specific wavelengths, and you can train a neural network using hyperspectral images to provide these insights to medical doctors. And then the focus of today's conversation is two examples, one in smart tunnel. As the name suggests, it's looking at tunnels and vehicular movements through tunnels and classification of the movements of those. And the second one is looking in the medical domain, looking at diagnostic retinopathy. And again, both of these use cases are using a piece of software from Fortis in Munich called the Neural Network Dependability Kit. And then the last experiment is using the compute card, and that's looking at Industry 4.0, and it's a Swedish example. So because that's not NCS, I won't focus on that one. Okay, so just a quick shout out for our colleagues in Fortis in Munich. They are a research organization funded from the Bavarian state, and they're interested in software dependability. And they have provided this NNDK that really opens up these neural networks because they are black boxes. And so you want to be able to reach into these neural networks and understand how does the model react to noise in the data? How does the data is how the net model is supporting the decision-making process? Are there any decisions supported by previous similarities in the training? And so the whole idea here is to get dependability and confidence in the inference process. Okay, and kudos to Fortis. That's an open source tool. Okay. Okay, that's it from me. Okay, thank you, Alice. I'll hand back to you.
Thank you very much, Finian, for your explanations. So now it's been introduced. You will have an example of a success story using Intel's VPU platform in the FED4SAE project in the medical sector. So I will now give the floor to UBOTICA and more specifically to Fintan Buckley, who is the CEO of the company. Fintan, the floor is yours.
Thank you, Elise, and good morning, everyone.
You should now have the control of the screen.
Okay, I'm just waiting now. There we go. Okay, so I just have 5 slides here to go through. I'll do it quite quickly. Just to give you an introduction to the company, talk about the particular area that we're focused on, some use cases, and then talk particularly about the experiment we did as part of the FED4SAE program. So UBOTICA Technologies was founded in 2017. We have a very strong relationship and history with Movidius, the company that designed the technology that's at the heart of the neural compute sticks. That is an ASIC or a chip called the Myriad chip. It's a vision processing unit that was really intended for embedding in cameras and for doing image processing directly on the data stream coming from the camera sensor. But it so happened that the architecture and the capabilities of the chip actually made it well aligned for actually accelerating the inference of artificial intelligence networks, which is how it's been used in many applications. So as I said, the founding of the company came pretty much around the time that Intel acquired Movidius. My co-founder, John Burke, was the CFO in Movidius, and our VP of Engineering, Aubrey Dunn, also worked in Movidius for a number of years. And in fact, all of our staff, apart from myself, are ex-Movidius. So we've a strong understanding and actually relationship with the Movidius team. We also have a facility in Spain in the region of Castilla-La Mancha, which is about 2 hours south of Madrid. And we have the team there because the university there worked on a previous Horizon 2020 program with Movidius and a number of other partners to develop a reference design called the Eyes of Things, and you can see this the output of that program on the if you Google it on the internet, and that was developing essentially a reference design around the Myriad 2 device, which is at the core of the NCS1 for use in mobile applications. The program itself finished up approximately a year and a half ago. I believe that it has been recognized as one of the best run 2020 programs. I know if a reflection on the people running the FED4SAE program, but the feedback from the Commission has been very, very positive on that program. At the end of that program, there was people working in the university who were available, and we ended up setting up a design center on the university campus and hiring a team of people there. So we've built up a large body of expertise around the Intel Movidius technology. So our focus is on providing AI solutions for edge-based computer vision applications. And our catch line is, as you see on the slide, photons in, information out. And what we're really trying to address is the fact that the world is drowning in data. We all have our mobile phones today where we can take pictures, and we rarely even have the time to go back and look at those pictures. And I think probably a good service that Google, or if you're an iPhone user, is you get these reminders of what happened 2 years, 3 years ago. And if we didn't have that, you would have so many images and pictures that you're taking that you never have a chance to go back and look at again. And a statistic that I came across recently is that the amount of data in the world is expected to grow 61% year on year by the year 2025. So a huge amount of data has been generated that neither individuals nor computers will have the time and the resource to actually to review. So our focus is on processing and discarding data at the point where it is captured. So really doing this on the edge. And as I say here, space is the ultimate edge because we do a lot of our work focus on the space industry. But why you want to do this on the edge? And 3 highlights there. We say power. You consume less power if you do it where the data is actually generated. You have fast response times. And you actually have autonomy. You're not dependent on any other pieces in the infrastructure. And of course, the other aspect here, which you don't highlight too much, is actually security, where you control the information that actually leaves the edge device. So we're active in 4 different segments. In the space segment, we were working with the European Space Agency and a number of European companies involved in the space sector to deploy the Myriad 2 device, which is at the heart of the NCS1, in satellites. Historically, when you're deploying technology in space, you're using technology that has been specifically designed for space applications. And there's a real focus within the European Space Agency to start to use what they call commercial off-the-shelf technology, or COTS, to be able to use state-of-the-art technology in satellites rather than having to use technology that has long lead times, because it takes time to design particularly silicon for space applications, and also it's costly and it's expensive. So the focus is to be able to take modern, up-to-date technology and rapidly deploy it for satellite applications. So what we're doing there is, first of all, we've done a characterization exercise to identify how the Myriad 2 chip is going to perform in the space environment, where what its weaknesses are, and to identify what mitigation strategies can be deployed with those weaknesses. We have developed lightweight toolkits, what we call the CVAI and also DPE, which in some ways take some of what OpenVINO is doing in terms of inference, but actually been able to do it in a lightweight manner, and also been able to use the image processing capabilities of the Myriad device, which is something you cannot do right now with when you're using the NCS devices. We're involved in a number of missions. One is for Earth observation, where we're imaging processing images taken of the Earth from satellites, and also for navigation applications, for moon landings, and also for object retrieval. And it's worth saying that the reason why you want to deploy artificial intelligence accelerators on board satellites is because of the volume of data that these satellites are generating. And a simple application of why you want this is that many of the images that are taken of the Earth from these satellites are discarded because you're imaging cloud. And by having logic and algorithms on board the satellites which can process the images and make an assessment as to the amount of cloud in the image, you can make a decision as to whether you want to discard that image rather than transmitting it back to Earth. Another reason why you want to do it on board the satellite is for time-critical applications such as fire detection. So if you can process an image and identify that there's a fire in Southern California and actually transmit an alert to say there's a fire, as opposed to transmitting the image and having the processing be done on Earth, there's a benefit there as well. We're also on the space side looking at methods for efficiently updating previously deployed artificial networks on board the satellites. So rather than having to upload complete models, looking at ways of efficiently updating those portions of the models that might have changed from updated training that has been performed on Earth. On the automation space, we've developed in partnership with Intel and with Lenovo a solution for automating content tracking within the warehouse environment. This has been done using the NCS devices, using OpenVINO, and with precursor to OpenVINO called the NCS-DK, which is not to be confused with the NNDK. And what we're doing here is using computer vision and AI to actually detect what you can see in the image, these data matrix codes, which are on the forklift trucks and on the warehouse content that's as it's moved around the warehouse. And what we are facilitating is the ability to inform the forklift drivers as to where the content is to go, and interfacing with a back-end ERP system for doing the business management around this content. This is a system developed using lightweight protocols like MQTT for communication. It's running on Lenovo Edge servers, as I said, using the Intel NCS technology. And this application is now live in operation in warehouses in the US and in China. The next element there, embedded AI and CV. And what this is looking at is a platform for doing turnkey IoT applications for computer vision and AI. And what we're doing here is we're taking the Myriad X technology, which is internal to the NCS2, and we're embedding it on hardware, which allows for turnkey, as I said, turnkey applications. And the idea here is not to require a host computer to actually transfer models onto your hardware for acceleration, but actually embed the whole thing on the Myriad itself. So what we've implemented on this platform is applications for doing things like road detection, people detection, face detection, data matrix codes detection. And we've recently done a proof of concept where you use this model for doing safety controls for e-scooters. So detecting that the scooter is not being used on the road, detecting if the rider is wearing a helmet or not, applications like that. So completely all you need to do is provide power to this, and then the device itself process the data stream coming from the camera, processes the image and transfers out the information over either a SPI interface or a Wi-Fi interface or what have you. Okay, and then the final segment is the biomedical segment, which was the subject of the application that we did with the FED4SAE.
One minute.
Okay.
Fintan, we might have to go quickly into the...
Yep, I'm getting there now, Alice. Yep. So the diabetic retinopathy is the biggest cause of vision loss in adults in the Western world today. And it kind of falls under the radar because it's only a subsect of our population that suffer from it, those with diabetes. But it is so prevalent that countries such as Ireland, the UK, and other geographies within Europe have actually put in national screening programs to try and detect this condition early on, where it can be mitigated through medical treatment. We deem this a good application for computer vision techniques and AI because even to the naked eye, it's the markers for diabetic retinopathy are quite visible, and you can see in the slide here these spots on the retina are quite easy to make out.
Okay, maybe we should move to the next one, just in light of the time.
Yeah, I'm trying to move. Okay, so what we did here was we took a network, we trained it to run on the Intel hardware. We developed a prototype with a company called Optimed who make handheld cameras for taking images of retinas. And in the prototype, implemented the system where images could be transferred from the camera to the PC, do the inference on the image, make an assessment as to the presence of diabetic retinopathy, and actually transfer that information back to the camera. Okay, and the architecture of the system is really twofold. On the top right, top left, you have the inference engine, which was implemented using OpenVINO and the neural compute stick. And then on the bottom left, we run in parallel the neural network dependability kit from Fortis. And what that's doing for us is making an assessment as to whether the decision that the network, the CNN, is making, whether it makes sense or not, based on the data that the network has been trained with. So what we're doing is during the training cycle, we build a database which takes a copy of what we call the neural activation patterns from one particular layer in the network. So every training image that's used to train the network has an entry in the database that says this is the neural activation pattern for that image. So then at runtime, if we are presented with an image for inference, which generates a pattern that we have never seen before from that neural activation, from that layer, then we will flag that as a questionable decision for the network. So that's what we did with the NNDK. We have successfully deployed this with our partner in the POC, and most importantly for us, we are now working with Fortis on a number of our space programs where we're actually deploying exactly the same technology. Okay, that's it.
All right, thank you very much, Fintan, for your presentation. I believe we will quickly ask you some questions. Please remember you can all ask your questions in the question box on the right side of the screen. So I'll start with one question, and then I believe Finian, there's one for you as well. So you mentioned Optomed. Can you quickly go over the business model you use with Optomed?
So Optomed was a proof of concept. So we have not executed a business engagement with them at this point. What we have done is we have assisted them with an assessment of whether they could use the Myriad X VPU as their sole processor for their camera, for the next generation camera. For a number of reasons, the conclusion was that they could not, primarily be actually for the difficulty in migrating their software base, which was ARM-based, onto the Myriad platform. But there's expectations that the next generation Intel device, which I think may be more suited to their application.
Okay, thank you, Fintan. I believe now, Finian, you have a question.
I do, but maybe we should go through Mohammed's presentation. Just watching our clock, we've only got 8 minutes, so
Okay,
I'd say let's jump. Yeah, thank you.
So yeah, there is another story on the agenda, another success story on the agenda today related to the industrial sector. So I'll give the floor to Mohammed right now. And Mohammed, the floor is yours.
Okay, so good morning again. Let me introduce you about what we do in ISSD. ISSD is focusing on smart cities and traffic problems in high-dense urbanized areas. So what we tried is to provide what we can call it a sustainable transportation in order to tame the pollution in urbanized areas and increase the comfort of the residents at the same time. So what we offer is several projects and several products that are focusing on junction management, dynamic junction management, based on what is happening in the scene around the junction. So the junction itself will try to allocate the best time sequences to allow vehicles pass in different phases. And it's one of the projects that we are doing in terms of smart cities. Another, I'm trying to move the slide. Yeah. This is in different scenarios. Some of the junctions are worked in a separate manner. Some of the junctions are worked on a city scale. So kind of orchestration happens in between the junctions in order to have a better result in an abstract view. Apart from that, we do some enforcement and safety systems like speed corridors and parking systems that will be based on plate readings and density estimation. And plate reading systems that we offer can support several standards from Arabic standards to Iranian and Europeans in order to provide much robustness in terms of product. So all of the applications are based on image processing and computer vision. And the study case or the project that was done in the program of FED4SAE is a smart tunnel. Well, let me state the problem. The problem is, as you can see in this screen, there are vehicular tunnels around Turkey and around the world, and those vehicular tunnels may increase more than 900 meters, or like several kilometers, like 14 kilometers, the case of Ovid in Turkey. So in order to monitor what is happening there and provide safety for the people who will use the tunnel, several cameras that can reach to the number of hundreds or if not thousands will be installed in the tunnel, and operators will sit in such room to watch out what is happening. And this kind of task is not easy. It's challenging for the operator to watch out all of these cameras at the same time. Even if we increase the number of operators, still there is a risk. So what the smart tunnel is? The smart tunnel is delivering AI to this system in order to help the operator to define and find out where an event can happen. By event, we mean like a car stopped in the, or a vehicle stopped inside the tunnel, or a vehicle go reverse direction inside the tunnel, or a pedestrian show up in a tunnel, a smoke, or a lift package. Maybe a wheel can have a problem, and some parts of the wheel of the car can be in the tunnel. So it's a risky case. So the system will analyze the scene, and it will shoot up an alarm to the operator's user interface. So the use of OpenVINO here took place in between the camera and the operator user interface. So OpenVINO will load a model, artificial model. That model will read the image, will understand the image, and will detect different objects, and it will drop out the result to the let's say event detector, and the event detector will alarm in case of abnormality happen inside the tunnel. So this is a brief about what is this project about with the FED4SAE program. The use of OpenVINO, as I have stated, is to load out the processing job from what we call legacy image processings, and use recent AI solutions. Apart from, we used the Intel hardware, the Movidius HDDL, which is a PCI loaded with several computer sticks in order to work in a server environment. So I believe that's what I have to brief about, and yeah.
Okay, so thank you very much, Mohammed, for your presentation. I have a quick question for you. So could you please tell us a bit more about your go-to-market strategy?
Yeah, so Smart Tunnel, we use the OpenVINO and we use the Intel hardware in order to deliver AI to such surveillance environment. Currently at ISSD, we are going to open more wider space for surveillance systems to be in parallel with the transportation systems and with the sustainable systems. So we will go to deliver such a platform to work on highways, because the highway environment is quite different from the tunnel environment, and to analyze the traffic situation and detect events on abnormalities in highways. And apart from that, another scope is crowd analysis. So all of these surveillance applications are in the ISSD timeline of future projects to be a product, let's say.
Okay, thank you very much for your answer, Mohammed. I will now let Finian speak, because I believe he has also a question for you.
Just watching our clock, Elise, I think we're out of time. Do I have time just to give some closing remarks?
Yeah.
Okay.
Okay, so maybe we only have 2 questions in the question box for the Q&A session, so maybe we should go over them so that people
That's fine if we have
their
time.
Answers.
Yeah. So listen, if there's things that you will obviously follow up after this webinar and answer any questions that folks may have submitted, and we can contact them directly. So that might be the easiest thing to do unless the time.
Okay, no worries. So do you want to go through the closing remarks now?
Sure. Okay. So, gosh. Okay. Watch the time. So, sorry. Obviously, guys, the AI revolution is only getting started. There's huge opportunities. It's going to be disruptive in every aspect of our lives. The barriers to entry are very low with open source software and low cost hardware. As Jamal summarized, Intel has a range of scalable hardware and software. And in the European context, there's a huge amount of talent here in Europe. The NNDK from Fortis was a great example. The Commission are doing their part in terms of enabling digital innovation hubs, and there's a new project. I think DigiFed is open to new applicants, so I encourage people to look at that. Intel is here to help companies to scale, and so please do connect with us. We're here to help. And in terms of final comments, I'd like to thank Elise and Regis and Blue Morpho for providing this forum, Mohammed from ISSD and telling us about Smart Tunnel, and Fintan and UBOTICA for the healthcare and other use cases, and for their bravery in telling their story. It's great to hear from people who've actually rolled up their sleeves, built and deployed applications in the real world. And lastly, I'd like to thank our attendees for turning up for their questions and interaction. I'm sorry we didn't have much time, but I hope this is the start of a beautiful relationship. And finally, thank you, and over to Elise to close this morning's session.
Yeah, thank you very much, Finian, for these closing words. So, as it was mentioned, there is another webinar coming up on the STM32 microcontroller. It will be handled by Marcello Coppola, and as today we will have some success stories. So don't hesitate to register. We will communicate on this very soon, so stay tuned. It will happen on the 19th of May at 10 a.m. Finian, you also mentioned DigiFed, so here are some information about the project and some key dates coming up. You can find all these information in the website, on the website. The website is digifed.org. As a reminder, this video will be available on our YouTube channel, and you can ask the slides by email and send me an email if you have other questions that you want to ask to our panelists. Thank you very much, everyone, for your attentions. We will come back to you with all the answers to the questions you asked, and I wish you a very, very nice day.
Thanks, Elise. Goodbye. Thank you. Great job. Thank you.
Thank you. Thank you, everyone.
Thank you so much.
Bye.
Bye-bye.